Hello guys, welcome to the course PLC for Beginner, and today we are going to cover lecture number 2 that will be going to be PLC wiring. So before going to the topic, let's get a quick recap of what we learned in our last lecture. So in the last lecture we covered topics PLC introduction, history of PLC, components of PLC, different programming languages used in PLC, and the last topic were different brands of PLC. So you must have a question in your mind that in the last lecture I told you that the PLC was introduced to reduce the wiring from our relay-based systems. PLC to reduce wiring. So in today's lecture you are going to learn that what amount of wiring was reduced by introducing the PLC for the industries. So without wasting any time, let's move. So if you remember, in the components of PLC we covered that PLC has two components, input and output modules. Input modules were sensors and output modules were actuators. And in today's video, we are going to cover different types of inputs that are given to PLC. So let's see what different type of inputs are there in PLC. So the first input is push buttons. The second input is sensors. Third input is limit switches. And the last one is analog input. So push buttons generally are of two types. Either they are of NO type, normally open, or of NC type, normally closed. Sensors are of three different types: PNP sensors, NPN sensors, and the last one is universal sensor. Limit switches are also of two kind, NO and NC type. And we have two different type of analog input, which is voltage based and second is current based. Okay. So in today's lecture, we are going to cover the push buttons, the sensors and the limit switches. There will be a separate video for analog input and output because it's a very different topic and it's a very vast topic. So before going to the input, let's clear some basics of PLC. So PLC mostly consists of three different types of notations, which will be C, X and Y. C will be a common, X will be known as our input and Y will be known as our output. If it's a PLC, let's assume it's a PLC. It will have common in both sides. It will have its inputs and output x0, y0, x1, y1, x2, y2. Okay, so common. What common is? And why it's called common? So basically common is another name for sink and source. You can say sink and source is Bible of PLC wiring. If your concept get clear for sink and source, you can do any wiring very easily. So if you remember in the component part, we also have power unit, and PLC runs on 24 volt DC. So here 24 volt DC will come in picture. So let's take a simple example. Assume this is our PLC. This is our common X0, X1, X2. So let's take a component from input. Let's take a NO type push button. Okay, so this is a NO type push button. NO push button. And you know how electricity flows. Basically, so electricity always flows in a closed path. So until and unless this switch is closed, the path won't be completed and the electricity won't flow. Like this, here let's make a circuit. We'll take the green color for circuit. Let's put it to the input module. So the electricity flows due to potential difference. So we have to create a potential difference in this circuit. So we have our 24 volt. So we'll connect our 24 volt DC here. Okay. So if there is 24 volt, what to create a potential difference, what voltage have to be here? It has to be a 0 volt. So potential is created. And now a path is created. And when the push button is pressed, the path completes and the electricity will flow. Here, for a basic understanding, I will let you know that there is a optocouplers which will emit light when path is connected, and it will give the signal to the PLC. So we'll cover that part later. First of all, we'll understand the sinking and sourcing. So let's try sinking. When 24 volt DC supply is connected to the common of PLC, then it is called sinking. Now we'll cover the sourcing part. So it will be similar. Let's make a PLC. We'll highlight it with red. This part is very important. Let's make an input part of PLC. This is our common. This is X0, X1, X2. This is our push button. Now here it was 24 volt. Then we have to create the opposite potential difference. So here we will give 24 volt supply here. 24 volt DC. So here is 24 volt. What has to be here at the common point? Yes, it has to be 0 volt. So that the potential difference is created. So when the push button is pressed, the circuit will complete and the flow will go. So let's write the definition of sourcing. So when the 0 volt DC supply is connected to the common of PLC, then it is called sourcing. Also, you can understand by one more thing, that when it is sinking and when it is sourcing. So when the 24 voltage is going out from the PLC, it is called sinking. And when the when 24 volts DC is fed to the PLC, it is called sourcing. Okay, so now we have a general concept clear with the syncing and sourcing. Now let's move to our input part of the PLC. I will copy this part. We'll paste here. So first, see push buttons. We'll cover push buttons. As I said, we have two different type of push button. First is normally open type, and the second is normally closed type. This is normally open type push button. This is normally closed type push button. I hope the concept is clear with the push buttons from the last explanation. Before sensor, let's cover the limit switches. Wait, I will make a order. Either concept is same, but the construction is only different. Push buttons are basically like a simple button. You can press it. You have seen you have seen like motor. You have a red and green button. They are like push buttons only. You have to just press it. But in the limit switches, they are. So this is how a basic limit switch looks. So the basic concept of limit switch is that assume that there are conveyor belts. Okay, this is a conveyor belt, and it is supposed to be in this position only. So if it goes left or in the right direction, it may fall, and there should be an alarm for this. So we will attach a limit switch here. We will put a limit switch here and a limit switch here. So if it goes in the left to right direction, it will press the limit switch. It will either press this side or this side. The limit switch will be pressed, and if the limit switch is on the NO or NC mode, it will change. So assume it were ideally in the NO mode, then it will switch to NC mode. So this is the basic concept of NO NC limit switches. Now let's move to the sensor. So let's cover the different type of sensors. So assume this is our sensor. It will have three different connections. First, it will have a power supply, 24 volt DC. It will have 0 volt. And the last, it will have an output. 0 volt is basically the DC supply. You have plus minus. Plus is we are connecting the plus part is for 24 volt, and the minus part is basically 0 volt. Okay, and we have our PLC here. We have common X0, X1. Okay, we'll connect our output to the PLC, and at the common, if we are providing 24 volt DC at our common, so the output of the sensor should be, guess, 0 volt, correct? 0 volt. So what is this type of connection is known as syncing or sourcing? Syncing, correct? Because at common we have 24 volt DC, so it is called syncing type. And this type of sensor is known as NPN type sensor. NPN type sensor. So here we can write NPN type. The output of the NPN type sensor should be 0 volt. Now let's make another sensor. Same here. It will have a 24 volt. It will have 0 volt. And we'll have output. Let's make our PLC 2. Common X0, X1. We'll connect our output to X1 assume, and here the common will provide 0 volt. So here it's a common. Here at common we have 0 volt. To create the potential difference, what should be at our output of the sensors? Guess. Correct. It should be 24 volt. So the potential difference will be created. And this type of circuit is known as sourcing type. And this type of sensor will be known as PNP type. So here at PNP, you can say the output of sensor should be 24 volt. Now come to the universal type sensors. So for the universal type, it's the same configuration. It will have 24 volt. It will have 0 volt. And instead of either 0 volt or 24 volt output, it will have both as a 0 volt or 24 volt and as output. So this will be known as universal sensors. So that's all for this video. We have covered the input of PLC, different type of push buttons, sensors and limit switches. And in the upcoming videos, we are going to cover digital output of the PLC. We are going to cover the second topic will be our analog input and output of PLC. And the third, which is going to be a very interesting video, will be PLC wiring on Siemens S7 1200 series video PLC. So these are going to be our next 3 video, and this will be our end of wiring of PLC. After that, we will directly jump into the software part where we will be learning the ladder logic. So that's all for this video, and if you enjoyed, please like, share and subscribe, and also press the notification button to be the first to know when our video comes out. Thank you.